Hey guys, and welcome to your 25th Java tutorial in which we are going to be going over the Java math class. Oh boy, you guys all love math, right? I hope the answer to that was a yes, but anyways, let's get started by first importing the math class. And the math class is located at java.lang.math. How convenient. So once we've imported it, this math class has a bunch of methods, and all of these methods are I'm using a keyword right now that I will explain later on. They are all static. Now, all that means for now is that remember when we had we had a scanner object and we called it s and we set it equal to a new scanner, and only after doing that could we actually use like s dot I don't know, we used s dot next int. Alright, there we go, right? That was terrible typing there. But remember that we always had to create an instance of the scanner class to do that, to actually access one of these methods. Well, that is not true for a static method. For a static method, we could just type the name of the class, dot operator, and then the method. And that is exactly the case with the math class. It has a bunch of static methods that we can use, meaning that we can access them directly through the actual math class, and we don't have to create an instance of this math class, which is very convenient, as you will later see for our purposes. So let's get started right away. It's going to be a relatively simple tutorial, so I am just going to create a system.out.println line here, so we'll automatically see everything that we do in our console window, because we're going to print out a line to that. So first method I wanted to go over is math.min. Now this takes two values and it can return the minimum of those two values. So let's say we have an integer 3 and integer 5. Well, what's the smallest? It's 3, so it should print out 3. Look at that. Bam, bam, 3. Alright, and it not only can it be an integer, it can also be a float or a double. So we can change this around a bit, like so. What value shall we get? Look at that, 1.1241. Great. Awesome. So this is working fine. And as you guys guessed, if there's a min, there's probably a max. And the max, once again, returns the larger of these two values, whereas the min returns the smaller value. So if we run this once again, we get 3.422345. So everything's once again working great. What method after that? Oh yes, also the famous square root method, sqrt. So the square root of 25 would be, well, 5. Let's just test that. Run this, hit OK, look at that, 5.0. And if it's not something that easy, square root of 17, for example, you need to find that to make a calculation. Bam, a very precise approximation of the square root of 17. What next? Well, yes, there's also a few rounding methods here. There's a method, math.ceil, which rounds a number up. So if we have a number 2.3, it'll round it up to 3. Let's just test that. Run this. Bam, what do we get? We get 3.0. And there's also math.floor, which rounds a number down. So if it's, say, 2.7, it'll round it down to 2. Let's see if my prediction is correct, and bam, 2.0. And there is the fairest rounding of all, which is math.round, kind of dubiously. So if we put 2.5 here, it'll round it up to 3. If we put 2.4, it'll round it down to 2. So it's pretty much your standard type of rounding. So once again, we round this 3, 2.7. It'll round to the nearest whole number. Pretty much all it's doing here. I don't know why I'm trying all these cases, just trying to show you guys how it works, I guess. Kind of a pointless thing, but anyways, let's move on. Math.pow. No, it does not pow you in the face, luckily, but no, it's actually how we use powers in Java. So the first number is your base number, and the next number is your exponent. So pretty much all that means is that we're raising the first number to the power of the second number. So 3 to the power of 5. Well, I happen to know that that's 243. Oh, look at that! Bam! Explosion. We're doing great here. So yeah, I don't know. Let's just try another number that's probably more common. These are all powers of 2. 2 to the power of 5 is 32, and bam, look at that, we get it out on the screen. So another method, absolute value, or ABS, ABS, as it's notated in programming, is its notation in programming. And all this does is it gives you the absolute value of a number, which is, I hope most of you know, is the distance of a number from 0, so it always has to be positive. So if it's negative 3.4, that's 3.4 units away from 0, so it just prints out 3.4. If it's positive 3.4, same beans, it's 3.4 units away from 0, so we get 3.4 as result there. And I also wanted to show you guys this math.random method, something very useful as a matter of fact. What this does is it gives us a random number from 0.0 to 1.0. And let me just show you what it does. We get like 0.9407 something something. If we rerun this program, we'll get 0.98 something something. Rerun it 0.31. So it's actually incredibly useful to have such a tool that can give us a random number. So yeah, definitely keep this method in mind. We will be using it later a lot. And let me just show you. Those are pretty much all the methods that I wanted to go over. And there's also some constants. Math.e is the famous constant e, which is approximately equal to 2.71 something else that I forget. But it's mostly used in compound interest. Some of you guys may know that. Some of you might not. Look it up if you don't. Very useful number. Well, you don't have to look it up, but I'm just kind of dictating the rules here. And another number that we will definitely use more in programming is math.pi when we pretty much perform calculations or operations on circles. And if we actually run this program, we'll get the closest approximation of pi, 3.14159, and same for e actually. Let's just see the exact value here. 2.71 something something something. Alright, yeah, so those are pretty much the two constants in the math class. And I believe that those are all the methods that I wanted to go over in this tutorial. So remember guys, min, max, square root, rounds, and ceil and floor go along with that. Pow, ABS, random, and the constants e and pi. And there are also a few other methods that are related to trigonometry, and we won't really have to use those methods unless we're doing something with physics, doing a physics simulation, or we're doing something that's more related to game programming. Now, if there's a slight chance that we might want to do something with that, I will probably definitely go over a review of trigonometric methods so that you guys will kind of understand how we can apply them and use them in programming. But so far, I don't see the need for that. But just to show you guys that this math class has them, for those of you that know what these methods are, they're sine, cosine, and tangent, as well as some other trigonometric methods that can be useful. So I believe that's really all I wanted to go over in this tutorial. So yeah, guys, I hope you kind of got a good view on the math classes, on the abilities of the math class in Java and what you can be able to do. So thank you very much for watching this tutorial, and I'm out. Peace.